Okay, this will be a little video talking about quadratic regression, doing some things on the graphing calculator. We will talk about how to find max and min, okay, also known as the vertex of a parabola. We'll talk about finding the zeros, and then get into an example briefly on what is the definition of a parabola, which deals with the focus and the directrix. Okay, so let's take a look. I'm going to do an example. This was from our Springboard textbook, and it was, let's see, there was some data given, and I'm actually going to be using these values. Okay, this was, I can't remember what the situation was, but it was some sort of word problem where you were given a table of value. I believe it was selling price. So these L3 here is the selling price, and then the L4 values were the monthly revenue. Okay, and I just had some other values in L1 and L2 from a previous example that I didn't want to type over because I was going to use them again. So that's why I used L3 and L4. Normally you would just go into L1 and L2. Okay, so anyways, first things first, if we wanted to take a peek at the plot of those and get a little scatter plot, we can go into second and then y equals, turn on our stat plots. Okay, and we're just going to go into the first one here and press enter. Let me get this stuff off the screen. And I'm going to go ahead and turn it on, and you have different types here to choose from. The first one is going to be a scatter plot. It's just going to show our points. Now again, most of the time you'll probably be using L1 and L2. I'm just happening to be using things that are in list 3 and list 4. So I'm going to go second 3 to change that to list 3, and my Y values were actually in list 4, so second 4. And then we have any type of symbol you want for the mark, color you want, and I'm going to go into the y equals and just clear out. This was at the previous example. So I just want to show what it will look like with no equation in there. So again, my stat plot settings look just like this. And now the trick, the best way to get the window set up, remember we had some pretty big numbers. Our y values were actually pretty big. We were up over 10,000. So you don't have to do that manually. There's a trick. If you go zoom, and then the bottom one there, zoom stat, what the calculator is going to do is it's going to look and find whatever numbers are in the lists that you told it, and it will fit your window to those numbers. Okay, so that's a decent scatter plot. And you can, at this point, if you wanted to press trace and kind of jump from point to point, scroll, and just kind of see what they are. But let's see if we can get an equation. It appears to me there's some sort of, maybe parabolic type thing that would fit these points. So the thing your calculator can do is find that equation. So it's going to take all the points into consideration, and it's going to find the equation that would maximize or would best fit these points. So to do that, we're going to go back to that stat screen where this is where we put the numbers in the first place. But this time, instead of edit, we want to go over to calculate, and we are thinking again that a quadratic formula or a quadratic equation is going to be the way to go. So I'm going to press 5, quadratic regression. And again, most of the time it'll probably be list 1, list 2. This one I just happen to have them in L3 and L4. Okay, so let's change those. The frequency list I'm going to leave blank. Make sure that's blank. We don't ever really mess with that in this type of problem. And then store the equation. If you want to have the answer to automatically go into the y equals, that's where you would put it. Right here I'm going to go the shortcut to tell it to put it in y1. The shortcut is alpha trace, and then you'll get all these different y1, y2, y3. I'm just going to go ahead and have the equation thrown in y1. Now, if you forget that step, this step that was optional, you can always just go down to calculate, and you can always just write the equation based on the a, b, and c values, and then just go ahead and manually into y equals and type the equation in. Okay, so just make sure we're clear here. The actual equation we're using is y equals the a value. If we were writing it down, I would just probably round it down to 2.196 x squared plus b 454.936, let's say, and then the c value is a negative, so minus 12,637. Okay, so don't forget to put in your x squared and your x if you have to manually write the equation, or if you ever have to enter it manually. But if we go into y equals, since I stored the equation, we're going to see that the entire equation is already going to be in there, and it's not rounded at all. It kind of leaves it real accurate for you. If you didn't store it, this is where you would have to type it in. Okay, so what that did for us now, when I go and press graph, it's going to show not only we still have the stat plot turned on from before, but now it's graphing the equation that we just entered into y1. So we can see that this did a pretty good job of finding the or fitting the points, pretty well. Okay, so a couple things we can do. Um, most of the time it's going to be really important to find a maximum or minimum. Okay, so this parabola, for example, since it opened downward, there's a point around here somewhere that is the highest point on the graph, which is the maximum. So let's go ahead and find that. Your calculator can do that. Okay, it's in the second trace. Okay, or it says calculate right above there. Second trace, and you'll see this menu here. There's an option for value for 0, which we'll use in a minute, and then max and min. Okay, this one has a maximum, so I'm going to press 4. And then you need to tell the calculator where to look. So it's going to ask for boundaries. So when it says left boundary, you need to go somewhere a little bit to the left. Again, we think our answer is in here somewhere. So for a left boundary, just kind of be somewhere to the left. Press enter, and it's going to set up a little boundary line. And then you're going to need to scroll to the right. So I'm just pressing the right arrow and just get safely past it. And now we press enter again. And now the calculator will only look in between those two, and it's going to find the highest y value that is in between those two lines. So when you press enter for a third time, you're going to get your maximum. Okay, so just remember to, in this case, the y values I believe were revenue, so that's the most revenue they could make for the month. And the x was the amount, I believe it was the price charged, or the selling price. So 103 would be the selling price that they should charge if they want to maximize revenue. Okay, because I think in this situation, if they charge, if you can see as the x values get bigger, if they charge too much, the profit's going to decrease because people won't pay it. But if they're charging, if the x values are too small over here, they're not making quite enough profit. So this point right here is kind of the maximum, like the middle ground. Okay, so let's talk about finding zeros now. Okay, in this graph, finding zeros would be answering the question, what price would they charge to have zero profit? Okay, because the zeros of a graph are when the y is 0. So technically for just a generic parabola, if the graph did something like this or whatever, we would be finding the values when the y is 0. Okay, so we're saying what's the x value there and what is the x coordinate there. Okay, those are the same x values that you would get if you used the quadratic formula to actually solve the equation. Okay, so let's do that on the example that we just did. Now, I think we're going to need to adjust our window a little bit because like when you find zeros, we're going to need to give the calculator left and right bound. So I'm going to need to see if this graph continues down here. I need to see a little bit down into the negative side. So what I'm going to do is I'm going to manually change the window. Let's go into regular window up here. Remember we did zoom 9 to get it started. But for my y minimum, whenever you need a 0, you need to see some negative y values so that you have both sides of the 0. So let's just do like negative 100 or something. Let's just see how that's going to look. So negative 100, is that going to be enough? And we're actually going to need to extend our x values out quite a bit as well here. Okay, because for the points given in the table, I'm not seeing this graph come down all the way. So let's see what happened there. If we go back to the zoom 9, actually, let me see what happened real quick. So there's that. Why don't we go back to the window, and I'm going to change this window to best accommodate the graph here. Okay, so I think I found the window. I'm gonna I'll kind of recap what happened. This problem was a little bit of a weird problem because if you think about the original data that we used, and this was actually number 26 from the activity. in the Algebra 2 book. But the x values that we had points for, remember this was our data that we used, was 80, 90, 100, and so on. So when we graphed those, where's my calculator screen here? Okay, the points given, that was an x of 80, that was 90, that was 100. So and actually to get this thing to go back down to 0, we had to kind of really extend the x window as well as the y window. So the settings that I ended up going with was this. I went x from 0 to 200. So those again were the prices. And then for the y's, you just need to make sure that you definitely have a negative for your y minimum so that you're able to go down past 0. I'll show you why in a second. But I went down to negative 1,000. Okay, and that gave me a graph like this. So we need to find the two zeros of the graph, and we kind of see again, here's one of them, here's the other one. So we'll find them using the calculator. So what we want to do is go into the same menu where the maximum and minimum stuff is at. So that's second trace. This time we are finding a 0. Okay, and we're going to do the same thing. The calculator is going to say, all right, where should I look? So left bound, right bound. So on these, we just need to be careful. Left boundary, if you imagine how you read this graph, when you read, you always go left to right. So as I'm reading this graph, I'm going like this way. Okay, so a left boundary needs to be somewhere down here below the x-axis. So what I'm looking for a left boundary is a negative y value. Okay, that would be a good left boundary. Enter. And now scroll to the right, and you need to go until the y gets positive. Okay, and you can go a little farther if you want to. And now we know that there's going to be a 0 in between, right? We went from a negative y to a positive y for our boundaries, so I know in between there's going to be a 0. Okay, and there's one of the zeros. It would be if this company were to charge $33, they would end up getting a monthly revenue of 0. Okay, and we could do the same thing to find the other one, but just make sure with this one things are going to be flipped around. Your left bound would need to be up here, somewhere above the 0, and your right boundary would have to be somewhere below there. And you should end up being able to get the other answer that way. Okay, so that's kind of using the calculator. I did want to talk briefly about the definition. So with this problem, it's kind of hard to see because the way the numbers work, so I'm going to look at another one. But basically what happens is with any parabola, there's always going to be some point directly under the vertex, okay, which is going to be called the focus point or focal point. And that's going to be some distance from the vertex. Okay, so that distance is what we call it P. And then that same distance, but going above, there's going to be a line up there that's called the directrix. Okay, and I want to talk about what's going on with those two things. Okay, so I'm going to go back to an example that we did with human cannonball example. So the situation was that a person was being shot out of a cannon. So kind of a fun situation. That red parabola is their flight. Okay, and it started out with, the equation was given to us as negative 0.112x squared, and then there was some other stuff going on. For this situation, we don't need to know the b and the c value in order to do what we're about to do. Okay, but here's the property. The situation also told us there was a camera mounted directly below the vertex. So camera 1, you can see there the coordinates were given. And there was a separate camera on the cable up there, the blue cable, camera 2, which is going to slide along as the person is flying. Okay, camera 2 would be up top on that blue line, always directly above the person. Okay, so what we did was we had the equation of the parabola, we found the vertex, found the coordinates of the maximum on the calculator, and then we were able to actually figure out, since this coordinate was also given, what we did the other day was figure out how far apart are they from here to here. Now we just didn't know it at the time, but that distance is P, which is going to be called the focal length or focal distance. And here's the relationship that we need to know, and I'll kind of verify it for you guys. There's a formula that says that distance P is always going to equal 1 over 4 times the a value in the equation, and the a value is, of course, the coefficient on the x squared. Okay, so that's a. So I just want to verify this with you and kind of show you what I mean. Focal length, okay, is 1 over 4a, right? So on our calculator, if I'm going to do 1 over 4, let's jot this down here. 1 over 4 times the negative 0.0112, right? And just be careful, we want parentheses around the entire denominator. It's 1 divided by that answer. Okay, so on your calculators, you could figure that by going like, let's get out of this screen here, clear off this old stuff. So the focal length, the distance to the focus, is 1 divided by parenthesis 4 times the negative a value, 0.0112. Okay, or a was actually negative, I'm sorry, it's just 1 over 4a, but our a was negative. So what we need to watch for, though, since it's a distance, we're really just going to worry about the positive answer, because you don't ever measure a distance negatively. So that 22.32, that is how far it was from the vertex to camera 1. That was 22.32, and you could verify that by subtracting the y coordinates, okay, straight down. So just the difference in the y's was 22.32. That is the same distance from the vertex to the directrix straight up. Okay, so what these things do is they set up the property. The definition of a parabola is the set of all points, okay, that are equidistant. Let me clear some stuff out. Okay, this point B, any point on the parabola, right? It has a distance to camera 1, as you can see by the segment. It also has a distance straight up to camera 2. That distance is going to always equal that distance, okay? And I have this is a little program called GeoGebra that can help me find the distances. So if we take a look there, that 54.81 is the distance from a point to camera 1. And notice that B camera 2, that is the distance from a point to camera 2. So as I move point B anywhere on the parabola, notice those distances are always the same, okay, no matter where we go. So that's what a parabola is. Okay, it's the same distance. It's the set of all points that is equidistant to a focus and to a directrix. Okay, so hopefully that helped with some of the terminology and calculator tips.